Now, good morning, everybody. Today, I'll start the topic steering gear, propeller, rudder, incinerator. These are integral part of your shipping or offshore ship applications. So, let's see some basic idea I'll give on these topics. So, first, let's define ship wheel and boat wheel. A tool utilized aboard water vessel to direct and manage the vessel's course. And what are the different components? Helm will be there, steering mechanism will be there. Linked to a mechanism, electrical servo motor may be there, hydraulic system will be there, mechanical system will be there. So the several systems are integrated together for maneuvering or moving the ship from left direction, right direction. Okay. A simplified toggle mechanism replaces wheel in modern ships. Additionally, a radar position indicator offers feedback to the helmsman. Helm of a boat or ship, the part of steer it, similar names also people will be using, like tiller, wheel, radar, steering gear. Several names also people will be using. Yeah, right side you can see one wheel, like automobile wheel you have seen. So similar way, if you steer rotate left side to right side, your ship will be moving left side and right side. And how it will be moving, I'll discuss later. Here you can see rudder. This is rudder. You see this top picture, this one vertical flat plate sort of thing. This is called rudder. Okay, rudder, and there is one propeller. Propeller, you can see special shape is there. Okay, so this will be propelling water pumped. So purpose of water is to give energy to water. So water, because water is getting energy, so water is giving repulsive force, or third law of reaction, Newton's third law. You can remember that if propeller is giving energy to force to water, water will be forcing propeller backward. So that force will be driving your vessel or ship forward, and rudder will be guiding left side, right side. Okay. Now different auxiliary mechanism also will be there. Auxiliary mechanism applying torque to turn the rudder. Hydraulic pumps will be there. Valves will be there. Okay. Two major pump type generally they'll be using, like Hele-shaw type and swash plate pump. We'll discuss later. There'll be piston cylinder arrangement. So like you rotate several turns of your wheel, but your rudder will be rotating only few degree angle. So then you need one mechanism so that like one rotation, 360 rotation of your wheel will not rotate the rudder 360, rather only few degree rotation will be there. So that mechanism, how this will work, I'll explain. You can see this bottom picture. So starter is here, hydraulic pump is here. From pump you have certain ram mechanism or one way valve mechanism is there. So finally that is converted into some degree angle of your rudder. So this is rudder. Okay, so whenever you are rotating the wheel, rudder will be rotating, but through different mechanism. So what is rudder? So rudder, actually it will be redirecting your vehicle. So it will be giving energy to fluid. So fluid will be giving reaction force. So that reaction force will be driving your vessel left side, right side, aft or port or starboard side. So rudder redirects fluid past the craft's hull or fuselage to induce turning or yawing motion. Rudder comprises a flat plane with hinged. So this is a flat plane surface actually, and this will be hinged. Okay, this is called rudder stock. This is called rudder stock. So here neck bearing is there. Neck. So this is called lower stock. This is lower stock. This is upper stock. Okay, and when rod is coming, rod or shaft is coming, shaft is rotating your rudder, and there will be bearings. Otherwise this water force will be break whole thing. So bearing will be holding in place and shaft will be rotating your rudder. This is called hanging. So different types of rudders are there. One is hanging rudder, another is simplex rudder. So many types of rudders are there. Rudder shape, if I take one cross section, so many time it will be like airfoil shaped. Okay, so let's say take one cross section here. AA will be showing like this. Okay, one cross section will be like almost airfoil, symmetric airfoil. So steering gear turning. The steering gear steers from 35-degree port to 35 starboard and back while the vessel move forward and its maximum continuous rate is shaft RPM, and summer load waterline within 28 seconds. If one power unit is inactive, then the rudder should turn from 15 degree port to 15 degree starboard side. So port side means left side, starboard means right side. Okay, if you see one vessel, okay, so one side will be port, one side will be starboard, and if you see from your ship, so left side is your port, right side is starboard. The hydraulic and hydraulic mechanism will be there, and actually you are using wheel, you are giving some force to your vessel to move left side or right side motion. Here one GIF picture is there. It is taken from Wikimedia Commons. You can see this wheel is getting rotated here at the top, and that force is going through this sheave or pulley. This is sheave, and this will be going through this one, and there this side also, left and right side both side is going like this, and finally you are rotating this one. Okay, this is connected directly to your rudder. So here is rudder. Okay, and this expanded form is here. This is expanded form here. So lots of gear mechanism is here. Gear mechanism, although you are rotating your wheel several turns, but gear mechanism is giving only small turn. And here one thing, like when you are rotating wheel, you are giving small amount of force, but you're giving several turns. So that force is converted into power. Okay, so let's say you are giving total power T into omega, torque you are giving, and omega is here. Okay, lots of turn you are giving, same power here it is going to your propeller, rudder, but in this case your torque will be increasing, omega is reduced. Okay, torque is increasing. So in that case you are giving more torque to your rudder, because heavy vessel needs larger amount of force. So that way you are giving lesser amount of angle, but you are giving larger amount of torque. So that will be helping to move your vessel left side or right side, or port side or starboard side. So one ship will have port side, I already told, and this will be starboard, and this will be stern side. Okay, so normally your propeller will be here, and propeller, in front of propeller there will be rudder. Okay, so I have, okay, so here you can see this top picture sketch. Propeller blades are here. These are called blades. If you can remember the pump lecture and turbine lecture, there we said these are blades. So propeller blades will be rotating, and this is hub. Okay, and this is giving energy to fluid. So it will be coming under the category of pump, not turbine. Turbine takes energy from fluid and it converts into electricity, but in this case you are giving energy to fluid. So, and pump also does the same thing. A pump will be giving energy to fluid, so the same function is there. So actually propeller is actually one type of pump category. Okay, so propeller or your ceiling fan, those are actually pump category, and propeller will be delivering fluid at very high velocity. So that high velocity fluid is passing over your rudder. This is your rudder. Okay, this is your propeller. These are blades actually. These are blades. Okay, so propeller blades will be rotating at high velocity, and the propeller will be connected directly to your engine or maybe electric motor. Okay, this may be engine or maybe electric motor. In podded propeller or separately installed propeller, so those will be run by electric motor directly. Normally heavy ships, they will have the propeller shaft connected directly to engine through some different connection mechanism. Okay, now propeller delivering fluid, those fluid will be passing through your, it will be touching the surface of your rudder. This is rudder. Okay, now you turn the rudder. Let's say my rudder airfoil is like this, my propeller is here. Okay, now propeller initially it was like so completely on the axis, same axis as your propeller. Rudder and propeller axis same. Then in that case vehicle or vessel will be moving in straight direction, that you are not turning. But in certain case you have this one, propeller axis is here. Now rudder you moved like this. Okay, rudder angle you made. So what is happening? Actually you change your flow angle. Okay, fluid angle is here. This is your angle of incidence, angle of, okay, you can remember your aerodynamics, angle of incidence changed. So because of angle of incidence change, so fluid is going straight, but your propeller angle change. So because of that, fluid will be forcing in this direction, the propeller. Okay, so force it is getting. So because of the force, propeller will be reacting, right? So when propeller is reacting, the vessel will be moving. When rudder is turned, so it will have certain lift force, and one force will be the drag force. Drag force will be along the chord line. This is chord line. Okay, this is lift force. Lift force. This is drag force. So drag force will try to reduce your speed of vessel, while lift force will be giving the leftward or rightward motion, or port side or starboard side turning. So that way the rudder is helping to turn your vessel right or left. Okay, so I started early so that I can leave quickly because I have passport appointment. So about 11:30 I'll try to finish. 11:54. Okay, so 12:30 around I'll leave. Okay, so as attendance seat is there, the people can take. So now I'll discuss about two pumps actually, basically. One swash pump, one will be radial pump. So these two pumps is used for your steering gear mechanism. So what are these two pumps? These are actually reciprocating type pump. These are reciprocating type pump. Okay, so reciprocating pump means like you have one cylinder, you have one piston, and you will have valve mechanism. So when piston is moving forward and backward, fluid will be entering in one port and it will be exiting in another port. So this way you are delivering, and this is actually fixed volume pump. If you have rotational speed fixed, then same amount of fluid will be delivered every time. And volume flow rate is low, but pressure development will be very high. So this is high pressure, low flow rate pumps. These are reciprocating or positive displacement pump. Displacement pumps. Okay, these are, so positive displacement pump will have different types. One will be reciprocating type, one will be rotary type, so many other types also possible. Now so the swash pump, it is also reciprocating pump, but one beautiful thing is that it will be giving constant pressure. Let's say reciprocating pump, like piston cylinder is there, one time moving up down, it will be delivering pressure. Let's say when it is moving up, pressure is delivered, pressure develop. Okay, but when it is fluid is sucking, it's not developing any pressure. When you're delivering, only developing pressure, so you are getting discontinuous pressure. But if you have multiple cylinder, then actually discontinuity will not be there. You have 2 cylinder, 3 cylinder, 4 cylinder. Okay, many cylinders are there, actually average pressure will be almost constant. So this swash type pump, they are having such mechanism. So this is called swash pump. Swash pump is like this. It is also a piston cylinder arrangement pump. So here I think you can see in camera, here pistons are there. If I rotate it, this is shaft, I'm rotating this one, shaft rotation, and you can see these black dots, holes are there. Here hole is there, the hole will be changing location. You see this whole size is changing. Okay, I'm rotating slowly and you see the whole size changing. This is cutout view, and if I have complete pump, then whole size means actually cylinder and piston. This one is piston and whole actual cylinder. If I rotate it, the piston is moving up and down actually. Okay, you see slowly So you see small hole is there, and when I'm moving towards this direction, hole size increasing. You see this hole size increasing. If I rotate in opposite direction, again hole size going down. Okay, so this is called swash pump. Several pistons are there, and one inlet port, another outlet port is there. This is inlet port, maybe this is maybe outlet port. So water will be sucked or any fluid will be sucked and it will be delivered there. And all the piston and cylinders, this cylinder and piston, they are connected to this inlet port and outlet port. So you rotate it, and the cylinders will be delivering one by one. When it is creating bigger space, that means it is taking fluid from your source, water source. And when this the size is going down, let's say this direction I am rotating going down, so that means it is delivering. Okay, so gap is created. I'll draw like this. I have one swash plate, and this is called swash plate. One slant plate is there. Okay, slant plate is called swash plate. Okay, so it is arranged such a way that, let's say you see the rotation, swash plate is also rotating. This is also rotating actually. This swash plate, this slant plate is also rotating, and this plate and this plate both are rotating. Okay, and both rotation is creating reciprocating motion of the piston. Okay, you can see, right? Not visible? Visible, right? Piston. Okay. So because this swash plate, this angle plate and this plate, the piston moving up and down, and you are getting continuous flow, almost continuous, because several pistons are there. Okay, it is creating continuous flow. But why this type of design? One beautiful thing is there, I will explain. So let's say this is my swash plate. I am making this a swash plate, and I have one system, piston here, piston here. Okay, piston will be here, and this one I'll make same size maybe. Okay, you see this my picture on a slide, and you see this swash plate is here, this one here, piston is here. If I rotate, piston is moving up and down. Now you see this one, this created one angle alpha. Now when it is rotating, the situation may be like this also. Piston is here, piston here, piston rotating, this is rotation you are giving. So in this case piston here, in this case piston here. Okay, you can see this alpha or beta. Maybe I can put some other values, maybe beta. You can see alpha converted to beta when I'm rotating. Okay, so that time you see the piston location changing. So volume, piston going to near top dead center to bottom dead center. Okay, so that way normal piston pump working, right? Like your cycle pumper also working same way, moving up and down. So this is also giving moving up and down. So one thing easier here, if I change the angle of this swash plate, my volume flow rate will change. Okay, let's say alpha initially I make 0, you rotate it, alpha means this angle, right? If I make both are 0, instead of angle make parallel to this plate, so in that case piston will not move up and down, so there will be no flow. But if I make maximum 45 degree maybe, so that time piston will be touching top dead center to bottom dead center, so volume flow rate will be high. So only changing my swash plate angle I can change volume flow rate. Instead of changing my other parameter, if I can change my swash plate angle, my flow rate will be changing. Okay, so this mechanism is used for your steering gear mechanism. Okay, so they'll be changing small part, they'll be changing flow rate, so accordingly your rudder angle will be changed. Okay, how much volume you are giving, based on that your rudder angle for 35 degree, 10 degree, 20 degree, so that angle will be changed. Okay, so this is called swash plate pump. Okay, and it is continuous flow, and it will and variable flow rate. Just you change this one, you can change your flow rate. So you can create variable flow rate. Just rotate slowly, you can see this piston moving up and down. Okay, so this side I am rotating, so slowly the piston gap is created, means it is sucking fluid. Okay, sucking fluid means it will be sucking, then when it is moving towards this one, again it will be delivering also. In one rotation, suction delivery, it will be happening. Okay, I have a swash plate connected to. Okay, now I have this is coming like this, then now this side also having, this is passing through some bearing. Okay, and it is giving rotation. So this bearing is here and it is giving rotation. Okay, this is called coupler. And output link, this is output link, and this is input. Okay, so this will be having reciprocating motion, or piston will be here, and okay, reciprocating motion will be here. So fluid will be taken in, fluid out, fluid. Okay, now draw this pump and swash plate. Swash plate will be connected to input shaft, and this is here, so that means my piston will be here. Piston is connected to this side here, piston will be connected to this. Okay, and this center distance is d, this angle is alpha, so this is drive shaft, and this is called shoe. Okay, now cylinder block, this is called cylinder block. Cylinder block, d is called piston circle diameter. This is called piston circle diameter. Dia d, and y number of piston, y number of piston, n piston speed, qth theoretical flow rate, and a piston area. Piston area means this area. If this is small d, so equals pi by 4 d square. Okay, now alpha offset angle, alpha is called offset angle, alpha offset angle, s piston stroke length. Okay, many terms are there in pump lecture also, so if some term unknown, so you go to the pump lecture, I think week 2 or 3, so there also you get definitions. Okay, so vd volume flow rate equals yas equals ya d tan alpha, because it is like this, alpha is there, d is here. Okay, and this is s, stroke length. So yas, s equals d into tan alpha. Okay, now theoretical flow rate, vn vd into n, so d a n y tan alpha. Okay, so this is your theoretical flow rate. If there is any leakage, then you can get actual flow rate, so then you can calculate percentage also. So normally we'll ask to calculate theoretical flow rate, but if I give you actual flow rate, then you can calculate the percentage also. Okay, so you can see again the pump. This is swash plate. This is angle alpha. Okay, and stroke length means if I rotate one time, how much piston moving from top to bottom. So that is your S stroke length. And area means piston top cross section area, and in number of piston is here 1 2 I think 4 or 6 pistons are there in this case. uh, and what are there? Theoretical flow rate, number of piston speed, n means how, what is your rpm. Okay, so that is your n, and s is stroke length, you already got. So theoretical flow you can calculate dany tan alpha. So remembering also easier, Danny. So another called Hele-shaw pump. Hele-shaw pump, this is also again reciprocating type pump. Because different mechanism they use, but basic funda is that reciprocating piston type pump or positive displacement pump. Okay, so they have given the name Hele-shaw pump. Hele-shaw pump is axial radial piston pump. Okay, so how it is radial? You have one shaft is rotating this one. You see this picture and slide, and it is connected to your pistons. Okay, so different pistons are there, and the shaft is eccentric. So because of eccentricity, shaft will be moving inside. Because of moving, your piston will be moving forward backward. Okay, that way you are getting flow rate. Okay, this is inlet, this is output, out this is outlet. Okay, there is piston cylinder arrangement. So flow rate is small n nas. Small is number of pistons. So number of pistons here, how many are there? 1 2 3 4 5 6. 6 pistons are there in this picture. A piston area. Piston area means like this is your piston area. Okay, this is your area. Okay, S piston stroke length, n is drive speed. So how much rotation is there? So normally it will be rpm. Okay, so if it is rpm, then you have to convert into rps. So how much how many times it is rotating per second. Okay, so for that we have formula also. Let's say this is my outer diameter, this is the eccentricity of shaft. Okay, my pistons are like this. So maximum dia dc, and your this dia is dr. So dc is dia of cam ring. This is called dc, dia of cam ring. The name they have given. Dia of rotor, this is dia of rotor. L width of rotor. Okay, how wide it is there. E eccentricity. E eccentricity means one circle, another circle is there. Big circle center is here, small circle center is here. This is eccentricity. Okay, eccentricity, Vd pump volume flow rate meter cube per revolution, and E max, maximum eccentricity, max. Okay, so Vd max equals pi by 4 dc square minus dr square into L equals pi by 4 dc square plus dr square dc minus dr, capital R I think, so I'll put capital R, L. Now actual volume displacement, E max equals E, actual volume of volume displacement. Displacement when E max equals E. So Vd max equals pi by 4 dc plus dr E L meter cube per revolution. Okay, so when rotor speed n, theoretical flow rate V d n equals pi by 2 dc plus dr el meter cube per minute. Okay, so this is your formula. So if any problem, simple problem is given, you should be able to use this formula and you can solve. So already we know that different types of pumps are there, and the pumps are having their own characteristics. So normally positive displacement pumps will have vertical HQ, you can remember, a head or pressure development, head in meter normally, flow rate meter cube per second or liter. Just you see different unit will have different values, but I'm trying to write in SI unit. So this is positive displacement pump, and centrifugal pump will have this type of characteristics. Okay, pump. So centrifugal pump, you can see that it is developing maximum head at within certain limit, so it cannot cross more than that limit for certain flow condition speed. But positive displacement pump, you see HQ curve, it is completely vertical. That means it can develop any amount of pressure. Okay, so you can see that centrifugal pump, it is having maximum pressure 20 bar and flow rate higher 3000, while other pumps, gear, vane, axial, these are actually positive displacement. Okay, these positive displacement pump are having lower flow rate, but pressure is higher. You can see this pressure is high, but while this one low. Okay, but flow rate, you can see centrifugal pump is higher flow rate, but your positive displacement pump has lower flow rate comparative to centrifugal pump. Now centrifugal pump you cannot use for all the applications because of pressure limitation. In certain cases you need very high pressure, but volume flow rate lower is okay. So in that case you can use centrifugal pump. Very high pressure and lower volume flow rate, you can use positive displacement pump. But in certain cases you need very high flow rate, pressure may be lower, okay, then centrifugal pump okay. But many cases multiple staging of centrifugal pump also helps. Okay, so based on your application you have to see which pump will be applicable for your case. For example, very high pressure development for your engine, so in that case centrifugal pump may not work, you can go for positive displacement pump. So positive displacement pump, many types are there. For example, your steering gear mechanism, they are using like swash pump or radial pump. Many cases oil and gas industry, they will be using gear pump, vane pump also there. Okay, so based on your application you have to select. So let's see one simple problem. A radial piston pump. Radial piston pump, I already told, the like eccentric shaft is here and pistons are here like this. Okay, and you are delivering fluid. So radial piston pump data is given, rotor diameter 63 and cam ring diameter 88. So this is 63, cam this is 88, cam ring 8, this is 88.9 or 90, and this is given 63, and vane width 50.8. so vane width is 15.8 given, volume displacement also given 115, eccentricity you have to calculate. Okay, center to center distance. So volume displacement pi dc plus dr by 2 L into E. So this value will be 115 into 10 power minus 6, and this minus 6 because you are converting 115 to meter. So 115 into 10 power minus 6 actually meter cube. Then pi, and values are dc 0.889 plus 0.0635, 63.5 millimeter is given, and divided by 2, and L value 0.0508 into E. Therefore E is coming 9.456 into 10 power minus 3 meter equals 9.456 millimeter. So this is your value. So this type of simple problem I can ask in your exam. Now we'll go through some basic fundamental of propeller thing. In other course, you may be studying in details about propeller, but here just to introduce propeller, what is this, how does it work? A propeller or screw on a ship consists of rotating hub. So hub will be rotating. This is hub. Okay, hub will be connected to a shaft, and shaft will be run by your engine. Okay, these are called propeller blades. I already told you. Okay, so most marine propellers are screw propellers with helical blade rotating on a nearly horizontal axis. In many cases, some slanted axis also possible. It pumps fluid. So you can see it pumps fluid or delivers fluid, and the reaction force will be driving your vessels or vehicle or ship. Propeller experiences losses due to their operation in fluid. Efficiency varies with propeller size. A larger size propeller will have higher efficiency. A smaller size propeller will have a little bit lower efficiency. And propeller will be experiencing cavitation. So cavitation already you may be knowing. So due to cavitation, there will be vibration, noise, and system failure. So you have to avoid cavitation. So very high speed or very high load, you have to check whether propeller will be cavitating or not. If it is cavitating, then you have to take action, or you have to change material, or you have to change design, or you have to change your vessel speed or condition, so that system can be safe and could be running for longer period. Marine incinerator. So another equipment will be there on your ship called marine incinerator. A marine incinerator or ship incinerator is used on board ship to burn solid waste. So because of MARPOL instruction, you cannot dispose your solid waste or oil or anything in the ship, in the water. So what you have to do, first you have to burn, and then you can dispose. That's okay. So it will be decreasing waste volume by 90%, and it will be minimizing the space needed for waste, because when you are going for long ships or lots of passengers are there, the waste will be very large. So in that case, you burn and reduce your waste. And again, if it is producing combustible burnt product or gas, harmful gas, so that also you have to take care. Okay, and those the high temperature gas can be used for power generation also in many cases. So manually operated or automated possible. Manual operated involves loading waste, ignite it, and monitor the combustion process. Automated system, just you put your waste and it will take automatic action. And normally International Maritime Organization, IMO, has the regulation, and you have to follow that regulation. And here one incinerator picture is there. Here all the waste will be burnt inside one closed vessel, and then you control the pressure, temperature, and whatever gas it is producing, you have to control. So thank you very much for today's lecture. Next day we will start new topic. Thank you.